that prescribe energy performance of manufactured products. So they brought what should be the energy efficiency of various products, and if there is any variance in performance of the products, the government, is basically watching over all these things, and then they take corrective action. So for creating an awareness, the label for all the products which are standardized or affixed on the product itself. You would have seen in the refrigerator, home refrigerator, they would have put some sort of a stamp which says, that is 1 watt per day for refrigerator. So like that, it is giving all the information on the products. So initially they brought refrigerators, room air conditioners unitary. Unitary means right from 1 ton, 1.5 ton, 2 tons, electric water heaters, electric motors, then agriculture pump sets, electric lighting, brass, industrial fans and blowers, air compressors. So we will just touch upon HVAC. HVAC means heating, ventilation, air conditioning. Heating is the temperature outside is less than inside. Ventilation is the sending the air out from the space or supplying the fresh air. So this ventilation is most important in the post-COVID situation, especially in the recent past. Now all the malls, theaters are getting opened, and all the hotels, restaurants are getting opened. So apart from air conditioning, they also require whether there is a proper air change. So the air change and supplying fresh air into the space, that will lessen the problem of virus spreading. So now the air conditioning. Air conditioning means it's a process by which the temperature, humidity, flow, and purity of air is controlled. The temperature for air conditioning application, it is about 24 degrees centigrade plus or minus 1, and the humidity is 55 to 60% humidity. Then flow and purity of air is also controlled. These are all the surrounding conditions based on which the air conditioning is worked on. So air conditioning removes all our discomfort. That is, it is cooled, warm, excess air moisture is removed. This is called dehumidification. The conditioned air is circulated gently, air is filtered, bad air is exhausted, fresh air is taken in, air is mixed with the outdoor air. Now the purpose of air conditioning is twinfold. That is, one is comfort, this is for human comfort, and this is for process air conditioning, for equipment, raw materials and goods. So major process in air conditioning applications, textile. In Coimbatore and all that is more applicable, because you have got a lot of textile mills and all that, where the humidity is the primary concern, which is getting solved by this air conditioning application. Then printing and paper manufacturing, close temperature and humidity control. Electronics and computer rooms, air cleanliness, low temperature and close humidity control. Pharmaceuticals, indoor air quality, positive static pressure in the space. Positive static pressure is most important because it should be higher than the atmospheric pressure. Atmospheric pressure 1.03 kilogram per centimeter square. It should be above that. And hospitals and operation theatres, quality of air. Quality of air, indoor air quality is most important. And hospitals, especially in operation theatres, they have got a filtration through HEPA filters, and they have a lot of fresh air application, and some of the air is taken out purposefully so that the same air does not. Then CNC machine control, and that is panel air conditioning. Now normally we call as a 1 ton, 1.5 ton. Normally the term which we are using in our room air conditioner, which we are using in the house, we say it is a 1 ton, 1.5 ton. So what is 1 ton? 1 ton is without increase in temperature, the heat required to melt 2000 pounds of ice in 24 hours. This is without increase in temperature is called latent heat. So each pound of ice, the latent heat of ice is 144 BTU per pound. So multiplied by 2000 pounds divided by 24, that is per hour. So 3000 kilocalories per hour. So this means in a room, if you are putting 1 ton, so if you are designing it for 1 ton for a room, so that means it is taking away the 12,000 BTU per hour of heat that is taken away by the air conditioning. So in turn, which it cools. This is air conditioning. How many more? Okay, right. So must be a transfer of heat to the for refrigerant to the liquid state. Liquid absorbs heat as changes to gas, then vapor releases as it changes to liquid. This is basically a refrigeration cycle. This is refrigeration cycle consists of compressor, condenser, receiver only in some applications, metering device, evaporator. So here, low pressure, low temperature vapor comes to the compressor. Again, the compressor is of a different type. One may be reciprocating, another one rotary, scroll compressor. So all these compressors are there. So depending upon the tonnage and depending upon the application, they are using it. So low temperature, low pressure refrigerant comes to the compressor, and the compressor is compressed to high pressure, high temperature, vapor. Then it is condensed to a liquid. Now the purpose of the condenser is to condense the high pressure by removing the heat from the high temperature vapor. It is condensed to a liquid, but the pressure is maintained up to this. So high pressure, medium temperature liquid comes to the metering device. The purpose of the metering device is it does the expansion. Expansion means the pressure is reduced. When the pressure is reduced, then low pressure, low temperature vapor comes to the evaporator. The purpose of evaporator is to evaporate the refrigerant, taking the heat from the source. For example, if it is in a room air conditioner, the one which is inside the room, which we are able to see it, that's called evaporator. And evaporator in a refrigerator is kept in the freezer chest. In the water cooler, it is in the tank. So like that, depending upon the application, the evaporator is fixed. Now, the purpose of evaporator is it evaporates. How does it evaporate? Because of the quality of, because the refrigerant is of low boiling point. Because of the low boiling point, the refrigerant is evaporated. So low pressure, low temperature vapor is coming back to the compressor, and the whole cycle moves. This is the generic refrigeration cycle. It is divided into high pressure side and low pressure side. The whole thing is plotted in a psychrometric chart, where the dry bulb is there, then wet bulb is there, then humidity, all the things are plotted. With this, we can even plot from outside air. You are getting mixed up with the return room air, and what is the room air conditioning room. So with this, you are able to plot the various conditions of coil entering, coil leaving, and all that. Then you will be able to arrive at whether the air conditioner is performing to the rated standard. Now, there are two types of refrigeration cycle. One is a vapor compression cycle, another is vapor absorption. Vapor compression is the cycle which we saw earlier with the compressor and all. Vapor absorption is, it utilizes the ability of one substance to absorb larger volumes of vapor of another substance when cold and then give them up when heated. So for that, they are all using this lithium bromide and other things and all that. Now, the vapor absorption refrigeration, they don't use the compressor. So because of this, though the initial cost is, installation cost is very high, operating cost is very less. But here, this initial cost is less, but the initial cost is, the operating cost is very high as far as the vapor compression refrigeration cycle. Now, these are all the main refrigerants which we are using. It is divided into pure and mixture. Under pure, your natural CFC. CFC means chlorofluorocarbon, hydrochlorofluorocarbon, then hydrofluorocarbon. This is natural. The ammonia, propane, and all that is carbon dioxide. Carbon dioxide also is a refrigerant. Earlier it was used, then it was discontinued in the middle. Now again it has gained a momentum, and a lot of people start using for CO2 also. Now CFC. CFC is R12. R12 dichloromethane. This is R114, R11. This CFC is totally banned. It is not, it should not be used because of the ozone depletion potential is very bad. And HCFC. Now, HCFC is R22 and R123. Even this R22 is banned in US. Now, in India, we continue to use, as per the Montreal Agreement, we can use it for another 5 years. So this HFC is R134A and R32, R120, these are all the things which are used presently in all air conditioning systems. Now, the mixture is zeotrophs and azeotrophs. These are all basically blend refrigerants. R407C. R407C is a mixture of R134A, R32, R135. The percentage varies. This R290, all the things are used. Now, for example, now different companies use the different refrigerants as a standard. R32 is basically used, manufactured and used by Daikin, and R290 is used by Godrej. R407C is used by Voltas and Blue Star. So like that, it is divided, and even though the ultimate result is the same, again, you know, the property varies. Based on that, they have a different thing. Now, this is the energy efficiency ratio wave. EER is equal to cooling capacity divided by power consumption. This energy efficiency determines the star rating of the air conditioner. You would have seen, you know, in all air conditioners, the split units and all, they are affixing single star, 2 star, 3 star and all that. How do they arrive at? The EER for 110 is, this is the 3514 is the capacity. This is cooling capacity in wattage divided by 1500 watts. This 1500 watts is the actual wattage consumed by the 110. For example, 110, how do you arrive at this VI cos phi? That's voltage into current into power factor. Voltage 230 multiplied by the current taken by 110 will be around 6 amps, multiplied by assumed power factor is 0.9, so which will come to 1500. So 3514 divided by 1500 is 2.34. If it is 1.510, again all the things will vary. Now this star rating is 2.3. In the case of star 5, 3.1 means, so that means the power consumption will be less. So as the star value goes up, the power consumption reduces. So now in recent past, star 1 has been discontinued by the government. So star 2 to star 5 is only available. Now all the star brand also will slowly fade away, and that will merge with ISEER, that is Indian Seasonal Efficiency Ratio. So now this star rating is being calculated based on one-time measurement, whereas ISEER is based on the it is seasonal efficiency ratio. It can be taken in winter, summer, autumn, and other things and all that. Then they take an average. They create about 40 bins and they create an average. Then they find out how efficiency is. So this energy efficiency ratio can be improved by increasing the cooling capacity. All the things are there. So energy saving tips for AC: set the room temperature between 25 and 7, and a hot day is expected. Turn on the air conditioner early rather than waiting until the building becomes hot. Adjust the air conditioner louvers. Have your unit regularly serviced. Install your air conditioner on a shady side of the building. Always prefer a higher star rated air conditioner than the lower rated one. So the conservation of energy refers to the efforts made to reduce the energy consumption and to increase the energy efficiency ratio. So while we are doing energy conservation, safety is the first thing which you have to do it. So, and avoid measures that have negative impacts on people and communities. So key steps for a successful energy program, various steps are outlined. One is to plan the effort and share the vision, design and implement the program, provide support and resources, check progress and evaluate results, sustain the effort. Now these are all the, I will end up my lecture with this slide. Now what we need, this is a new behavior for lighting. My colleague has already explained, you know, about the lighting, how judicially you have to use the lighting and all that. Then technology, then transportation, heating and cooling, personal comfort. Then implement strategies, kick-off assembly, energy conservation posters, announcements, bulletin boards, competition, rewards and incentives. So, and this is the holistic approach in practice. So the maximum energy efficiency is the 3 prolonged energy conservation, behavioral change, all lead to energy efficient technologies. So with this, I am ending up my short lecture. Sir, I am finishing, sir.
Okay, sir. Now we have posted this feedback link in the chat box. So kindly open this link and fill up the feedback, sir.
So we have some questions.
Mohan, sir.
Yes, sir, please.
We have posted this feedback link in the chat box. You
Okay,
can
okay.
ask the students to click the link and open it. They will get the details to be filled. Let them fill it, sir. This is the feedback form about this webinar. Our deputy director has already joined, Mr. Sadiraj, sir.
Welcome, sir. I welcome you, sir. So,
Yeah.
welcome you, sir. Sadiraj, sir. Welcome.
Yeah, thanks for inviting to participate.
Sir, I have some few questions related to this HVAC.
Yes.
Sir, just a minute, sir. So regarding this refrigerant, R32 is the most widely accepted right now.
Yeah.
But R32 is having a flammability issue problem is that it is categorized as A2L.
Yeah.
Moreover, the critical temperature of this R32 is very low when comparing to R22 and 407C and even R290. So R290 is recommended in R290, but still it is critical temperature is lower. So it's around 72 degrees centigrade. So because of this reason, the performance is degraded very significantly, especially during summer, which the installations in Delhi. For example, Delhi, they are having a maximum temperature of around 45 to 50 degrees centigrade. Even they reach up to 50.
Yeah.
But the R32 is having a poor performance. But I don't know why the manufacturers are still they are depending upon R32. That is a number one question.
Yeah.
And number two, most of the installations, the expansion valve is attached with the outdoor unit. In some installations, the outdoor unit may fix at the third, fourth floor, but their indoor unit is in the first floor. After expanded, the cooling starts, the refrigerant starts evaporating. But the total length between the outdoor and indoor unit, the cooling energy is wasted. I don't know how we can go for the energy conservation in such type of installations. The installation, the problem is with the manufacturers, but they're having some standard for manufacturing the outdoor and indoor units. But the problem is in the it's not correct. And some so how to face this type of issues?
Hello.
Yes, sir. Yes, sir. Yes,
Yes.
please.
There was a discontinuity in the net connection for a few seconds.
Okay, sir. Okay.
Now, for your first question, R32, you see, now R134A is widely used. And R32, what happened? Daikin started manufacturing R32, and for the commercial operation, they started telling it is our own refrigerant, so we are fixing it in an air conditioner. And R32, as you said, and it is. I will not say it is flammable, but if you don't take much care about the storage, or if there are many leaks and if there is a proximity of fire is near that, and they have found out the fire catching the fire is not that alarming. The technician has to be take more care in handling that R32. R32 about your clarification is widely accepted. But as far as the commercial is concerned, the R32 is Daikin is using it in full swing, and R290 is used by Godrej. Now what happened? The R32 they have started using it in the market, saying that it is the one of the best refrigerants available in the market. So the market consumption is, they go only by the manufacturer and the name of the brand.
Okay. So now even for LG also they manufacture with R32 compressor systems, AC systems. Even Blue Star also they are shifted to R32.
Yeah, correct. You are right.
I think in mostly everyone, because they're after phase out of R410A, they are shifted to R32. But it's good. But the thing is, global warming is around significant. Global warming is there 650. I think R32 is having a GW value of GWP of around 650. But the thing is, low critical temperature, high critical pressure. So this will leads to some restrictions in usage in air conditioners especially in tropical climatic conditions facing
And,
more than 2 degree.
And
I
for
mean,
R32 ODP, ozone depletion potential, they
Is
say it
zero.
is almost zero.
yes, sir, that is zero, but global warming is significant. Now the
Yeah.
Paris Agreement says more focus on global warming. So that's when
Yeah.
yes, sir.
Yeah,
Okay,
yeah. It is a universal problem which has to be looked into. And about your thing of having indoor unit and then outdoor unit in the very far off place, and the manufacturer already prescribes when you are connecting the split unit from indoor to outdoor, there should not be more than 6-7 belts, and it should not be more than 20 feet. So, in case you have to have more than 20 feet, then you have to size the liquid line in such a way so that it takes more refrigerant. Then what happens, for example, if you take 1.5 ton air conditioner, 1.5 ton split, it is supposed to have only 1 to 1.25 kg of gas. When you have a lengthy pipeline, then what will happen, more gas will be there. If you start charging more gas, then what happens, the compressor should be in a position to pump the gas for a longer time. So all the practical problems are there. And regarding your expansion wall being kept outside in the expansion wall or capillary tube kept in the outdoor unit which is far off. See, earlier when split units were floated in the market, the capillary tube and all the things were fixed in the indoor unit only. But because of customers' problem, they were telling it is giving a hissing noise. Normally in the expansion wall you get hissing noise. That hissing noise is coming inside the unit, which is a disturbance or nuisance to them. Suppose if it is in their bedroom or something, they said it is not advisable and all that. So right from carrier, everybody, they started shifting all the expansion wall capillary tube to the outdoor unit. That is how the whole thing had come. But only thing about your loss of conservation energy for the lengthy pipeline, you have to see that you insulate it in such a way so that you don't lose any temperature outside, which will be detrimental to the compressor performance.
Okay, sir. Okay, sir. So thank you, sir. Thank you for your information.
Yeah.
So this feedback form.
So Satiraj sir, you want to say something?
Yeah, sorry for joining little late because of preoccupation actually. So on behalf of PCRA, welcome for this session again. I hope the session was very useful from participants.
Yes, sir, definitely it is very useful to our students, and few of our faculty member also is interested, show they interested to join in with this program. I think they are also get benefited. Thanks for the wonderful opportunity provided by Ratna Sabhavadi sir and also Vasudevan sir, and also from Satiraj sir, so for providing this opportunity to provide a very good information to us. I thank you, sir.
Yeah, please. For one thing, I just want to conclude from my side. And
Okay, sir,
PCRA being under Ministry of Petroleum and Ministry of Petroleum and Natural Gas, Government of India, it's a research society to promote energy conservation and best engineering practices, which leads to conservation of energy in large scale. So if any students or staff members who have got any concepts or a project, any project or a project which is in the area of energy conservation, any type of concepts or a project which leads to considerable energy conservation can approach us for the project funding. We do have some provision to do this. There are some set of conditions which will be stipulated in a detailed way. If interested people can approach us. So, on behalf of PCRA Southern Region, we just want to express our requirement also that we welcome such kind of innovative ideas and then research projects where we will have a sufficient or a considerable energy conservation. We should not have any precedents in the past. That's it.
Okay. Thank you, sir.
Any people who are interested can approach us. That's what I just want to say.
Contact details.
Yeah.
Contact details. Your contact details.
I'll share my contact details. You can for any kind of energy conservation.
Sir, I will give the email ID and cell number of Mr. Sadiraj, sir.
Okay, thank you, sir.
I will inform you. No problem. I will send it.
And students who wants to have some idea about the energy conservation and various activities of PCRA, you can log into pcra.org. It's our official website. There are a lot of energy conservation tips and techniques in various fields, not only in engineering, even for transport or for agriculture or in a domestic line where on our day-to-day utilities, whatever we use in our daily life, routine life, there are also energy conservation tips and techniques that are being demonstrated in a large way. People can visit this and then go through the tips and techniques, whatever has been illustrated over.
Thank you, sir. Thank you, sir.
Thank you. Thank you. Thanks for being a part of this.
Thank you, sir. And students can fill their feedback form, and those who have filled, they can leave, sir. It is available in the chat box. This link box.
Okay, sir. I will inform, sir. So, dear students, please fill the feedback form before you are leaving, please. So, the link is available in the chat box. Please fill the feedback form before you are leaving, please. So, thank you, sir.
Thank you, sir.
Thank you, sir.
நான் ஃபாலோ பண்ணிக்கிறேன் சார். நான் ஃபாலோ பண்ணி வாங்கிக்கிறேன் சார். ஃபீட்பேக் போட்டுருங்க. ஃபீட்பேக் போட்டுருங்க. அந்த ஆளுக்கு எதை கேட்குறாரு அவரு? ஃபீட்பேக் அவர் கேட்குறாரு, சார் கேட்குறாருங்க. நீங்க அவங்களுக்கு தேவைப்படுங்க. அவங்களுக்கு எதாவது அவங்களுடைய இது அசஸ்மெண்ட் நான் போட்டேன். Students, please fill the feedback form